Okay, let's look at our final topic in statistics, which is problems with the normal distribution. If you go on to take another statistics course, you're going to spend a lot of time doing problems just like this. So in the previous course, we talked about finding z-scores. So here, what we're going to do is use z-scores for prediction or probability. So in this example, we're talking about cholesterol levels. The mean is 178. The standard deviation is 40.7. What percentage of men in this age range have a cholesterol level less than 239.15? What we'll do is use the same formula we used in the previous section, the z-score formula, data point minus the mean over the standard deviation. So if we plug in these three numbers, we find the z-score corresponding to 239 is 1.5. What we'll do next is use this 1.5 to get some numbers. So what we'll be doing is using this table. This table is given to you in full in the e-text. Let me show you that. So if you go to the e-text section for 12.5, you'll see this table and it lists lots of z-scores along with percentiles. Now you'll see negative z-scores and positive z-scores. Remember, a negative z-score is fine. It simply means that it's below the mean, whereas positive means it's above the mean. So what the percentiles are the areas corresponding to each z-score. So you can see they start out very small and increase as the z-score increases. Notice the center right here at 0. If we're talking about 0, well, then that's the center, that's the mean, and 50% of the area is included. And then we keep going up. We get pretty close to 100% towards the end. So this table that you see here in this slide is just a small section of that bigger table. We computed a z-score of 1.5. If we go to the table, that corresponds to a percentile of 93.32%. Have a cholesterol level less than, and that less than is important here, 239.15. Now, the previous problem was fairly simple because it said less than. Another type of common problem is between two given items, which is okay. We'll do something very similar. We'll still convert both data points into a z-score. We'll use the same table, 12.16, from the text to find the percentile from each one. We will subtract the smaller percentile from the greater percentile. And what this does is it removes the lower portion so that we only have the area between two data points. So in this example, we're talking about self-employed Americans work with a mean of 44.6 hours and a standard deviation of 14.4 hours. What percentage of self-employed individuals work between 37.4 and 80.46 hours? So these are the two data points we want to see in between. We run the z-score formula twice, once for each of those data points. Now, this first one is negative because it's below the mean, and that's okay. Once we've found both z-scores, a very common student mistake is to subtract these, which we are not allowed to do. We can subtract areas or probabilities, in this case percentiles. So what we do is we take these two z-scores, go to the table in the text, and find the area that corresponds to each. So the percentile corresponding to negative 0.5 is 30.85. And z-score 2.5 is 99.38. Now, if we want to know the area in between, we have to subtract both of those. We do the upper minus the lower. So this 80.6 hours is pretty high. 99.38% of people work less than 80.6, which makes sense. That's a lot of hours. 30.85% work less than 37.4 hours. So if we subtract those two results, that'll give us the area in between, which is 68.53, which means 68.53% work between 37.4 and 80.6 hours. Now, when it comes to these normal distribution problems, there's only three types. The simplest one, which we looked at first, was simply a less than problem. We compute the z-score, go to the table. The solution is the percentile. Now, we didn't look at a problem like this, but if we had a problem that said greater than or more than, we would do pretty much the same thing with one extra step. Percentile measures area to the left. If we get a problem that says more than or greater than, you simply take the percentile and subtract it from 100%. Because the whole curve is 100%. If you subtract off what's to the left, that'll give you what's to the right. And then finally, we looked at a problem like we just did where it was in between. You will take two data points, convert them into two different z-scores. Take those z-scores, go to the table and find the percentiles corresponding to both. You will take the upper percentile, subtract the lower percentile to get the percentage in between.